Okay, sequences with quadratic and cubic rules. Our learning goal here is to find the rule for the nth term in more complex sequences. Those complex sequences are quadratic and cubic. So far, all the sequences we have looked at have been arithmetic, meaning the rule for the nth term is linear and takes the form of u sub n equals an plus b. Okay? The rule for the nth term can be found algebraically using the methods of differences, and this method is particularly useful for more complex sequences. Okay, so we're going to look how to do this with an arithmetic sequence. So remember, an arithmetic sequence is where it changes the same every time. Well, this one is, or plus 3, plus 3, plus 3, and plus 3 forever. Okay? From here, we could put it in a table. Alright, now we're going to look at our difference between them. Well, that's what we're used to. We're used to seeing that here. 3, 3, 3, 3. Okay, we know it must be an arithmetic sequence because 3, 3, 3, 3. Alright, as the first row of differences is constant, the rule for the nth term is linear and takes the form of u equals an plus b. This is our big part here. Okay, as the row of first difference is constant, the rule for the nth term is linear and takes the form of u equals an plus b. Okay, this is like I said, this is our big part right here. Okay, where they become constant, that's where, okay, we stop with that part. So by substituting values of n into the rule, okay, each term can be written in the terms of a and b. So what we're saying here is all I'm going to do is take a 1. So I'm going to go like 1a times 1 plus b, okay, and a of 2 plus b, and so on. Yeah? So as I did that, okay, we see a, 2a, 3a, 4a, and 5a. Alright, that's just 2 times a, 3 times a, 4 times a, 5 times a. This b is not changing. Okay, notice that. The b doesn't change. It's b every time. The last variable doesn't change here. And if I was going to take the difference, say instead of having my term was 4, 7, 10, 13, and 16, my first position was and I got the term a plus b, and then I got 2a plus b, and 3a plus b, 4a plus b, 5a plus b, 6a plus b, 1000a plus b eventually. Well, the difference between each of those, if I subtracted them, if I did 2a plus b, okay, minus a plus b, well, I would lose this, or I would lose these b's, and 2a minus a is just a. And that's the same for everything here. So my first difference is a. Therefore, if this a is the same as this a equals 3. A plus b equals 4. Okay, b equals 1. How did we figure that out? B equals 1. A plus b equals 4. Well, I know a plus b is 4. So a plus b equals 4. And if a equals 3, 3 plus b equals 4, b equals 1. Okay, so this is definitely a lot of work for an arithmetic sequence, and there's a reason we don't do it like that for them usually, because it's a lot of work and we can do it a little bit faster. However, when we have not arithmetic sequences, well, then this becomes the way we need to do it. So, deduce the rule for the nth term for the sequence 0, 7, 18, 33, 52. Okay, so we've put them in a table. I would highly, highly, highly suggest you pause the video and make a table with space below to make some more rows. Okay. Now for here, we're going to just make our first difference like we have before. So difference between 0 and 7 is 7. 7 and 18 is 11. Okay. 15 and 19 here. Now notice, these are not the same. So usually we've been dealing with ones that are the same. Well, these aren't. Okay. So this is not an arithmetic sequence, but we can do another difference. We can do what's called the second difference. So the difference between 7 and 11, okay, 11 and 15, 15 and 9, and we find, let's just delete that instead, we find that that is 4, 4, and 4. Okay, well that is a constant there. So the row of second differences is constant, and so the rule for the nth term is therefore a quadratic. Meaning, this is first degree, second degree. Okay, so second difference, power of 2. And we get in this form of a n squared plus b n plus c. So with the first difference, okay, like we saw in the first one, it was just a n plus b. Now we're going to go second equals a n squared plus b n plus c. So from here, what we're going to do is we're going to take our term and plug it into each of these. So meaning, in my first position, I'm going to have 1, I'm going to have a times 1 squared plus 1 times b plus c, which is going to give me 1a, or 1a plus 1b plus c, so just a plus b plus c. Okay, that's what's going to go here. In the second one, okay, we're going to do the same thing. Okay, it's 2 squared a plus 2b plus c, so 4 plus 2, 4a, sorry, 4a plus 2b plus c, and we're going to do that for all of these, and we get this right here. Okay, so again, what we're saying is this first position is the same as this first position. This 0 is a plus b plus c. Okay, this 7 is 4a plus 2b plus c. Okay, and so on. Now we don't have enough information yet with what we have revealed here to figure it out. We're still missing too much information. Okay, but now we're going to find the difference between these, just like we did here. Okay, so we said the difference between 0 and 7 is 7. Well, we're going to find the difference between a plus b plus c and 4a plus 2b plus c. And I'll do that in red for us. So, and I'm a little bit out of room, so I'm going to do 4a plus 2b plus c and a plus b plus c. And what we're really talking about is just how far apart they are. Okay, so how far apart are they? They're 3a apart, so we're just subtracting really. Okay, 3a plus b, okay, and we're gone. Alright, the c is going to go away, so the difference between these two is 3a plus b. The difference between these two is going to be 9a minus 4a is 5a. 3b minus 2b, okay, is 1b. C minus c is just 0. Okay, so we notice, and if we did that for all of them, I'll erase that, and there we go. Okay, so we notice the b doesn't change. Okay, and now we can see, if we think back to our first example, hey, this is very similar. Okay, what is we're going to subtract these again, and we'll get, well, 5a minus 3a is 2a. I'm sorry, I know that's a little bit hard to see. 2a. Okay, the b's are going to cancel out. 7a minus 5a is 2a. B's cancel out. 2a, 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 2a. Okay, now here we're at our constant. All right. So our second difference is 2a. All right. Now we need to figure out what our variables equal. So if we compare our tables, okay, those are the same. We just have changed how they look. Okay, we know that this 4 is the same as this 2a. So 2a equals 4. So we divide by 2. So a equals 2. Let's set that off to the side. A equals 2. Okay. For our second difference, all right, we'll do that in red. Second difference, we know 7 equals 3a plus b. So 3a plus b equals 7. Okay, we have two variables, but we already know what a is. A is 2. So we have 3 times 2 plus b equals 7. So 3 times 2 is 6. 6 plus b equals 7. Okay, minus 6, minus 6. B equals 1. Let's put that over here. And finally, we need to figure out what c is. All right. We have multiple places we could plug that into. Let's just make it easy on us. We know 0 equals a plus b plus c. So a plus b plus c equals 0. Okay, we know a and b. A is 2, b is 1, plus c equals 0. We put 3 plus c equals 0, minus 3, minus 3. C equals negative 3. So all together, okay, put everything together, we will get 2n squared plus b, 2n squared plus, well, b is 1, so 1 times anything, we don't need to write, n minus 3. Okay, let's check here. All right, and there we go. Now, and here's our answer. Here's what we have. Okay, now what's important is just that you compare the right things. We used the lowest values. We used this 4 and this 2a. We could have used this 2a and this 4. That doesn't make a difference. Okay, but we could have also said 15 equals 7a plus b. We did not need to do 3a plus b equals 7. All right, it's easier to use the lower numbers usually, but not always. Okay. All right. Let's do the next one. All right, deduce the rule for the nth term for the sequence -6, -8, -6, 6, and 34. Okay, before we do this, I want you to set this up in at least this first table. So position, term difference, first difference, and second difference. So set this sequence up in a position, term, first difference, second difference. Pause it and then come back when you're done. Okay, so you should have something that looks like this. Okay, the difference between -6 and -8 is -2. Okay, -8 and -6 is 2. Okay, and so on and so forth. Then the difference between these is 4. The difference between these is 10. The difference between these is 16. From here, we still haven't gotten that they're all the same. Well, we find, yeah, you guessed it, the third difference. So 4 and 10 is 6. Okay, 10 and 16 is 6. Okay, so we found it. All right. So the row of third difference is constant. So our rule here is therefore a cubic which takes the form u in, okay, u sub n is, I'll write that a bit bigger, I know it's quite small, a n cubed plus b n squared plus c n plus d. So hopefully you can see a pattern now from our first arithmetic one, okay, to our quadratic, and now our cubic with a power of 3. Okay, we add our powers going down. So a power of, if we did have a fourth difference, okay, we would have a n to the fourth plus b n to the cubed plus c n squared plus d n plus e, okay, and so on and so forth. But for now, we don't have that. That's just an example. Okay, so we have this here. All right, so we're going to do what we did on this last problem and come up using our formula. So let's go through, and so I know if I plug a 1 into this, okay, if I plug a 1 into this, I'm going to get 1 cubed is just 1, so 1a plus 1b, because 1 squared is just 1, plus 1c, because it's just 1, plus d, so a plus b plus c plus d. Yeah. Okay. For 2, we're going to get, well, we're going to get, plug in a 2 for everything here, so so we have 2 cubed a plus 2 squared b plus 2c plus d. Okay, we can't leave it like this. We need to simplify it. So that's 8a plus 4b plus 2c plus d. Okay, I want you to pause it and find these 3 terms here for 3, 4, and 5. Okay, you should have found what we have here. Now, just like before, okay, we need to find our first difference. So I need to do our terms minus each other. So I need to do 8a minus a. So I'll get, so this should be 7a, 4b minus b, or it will be 3b. 2c minus c is c, and d minus d is just going to stay. Okay. We'll do the next one. 27a minus 8a is 19a. 9b minus 4b is 5b. And 3c minus 2c is just c. Okay. Again, find these next two and then pause it. Or pause it, then find these next two. Okay, so we should have this going along. Alright, now again, we have not found, we've just only found the first difference with variables. We need to find our second difference and our third difference. I want you to, again, if you think you understand, go ahead and try it. Okay, So now for here, we're going to have 19a minus 7a is 12a. 5b minus 3b is 2b. C's cancel out. Okay, 37 minus 19. Okay, we should have 18a plus 2b, and 61 minus 37 is going to be 24. 24a plus 2b, 9 minus 7b. Okay, again, we found our second difference, and now we need to find our third difference. 18a plus b plus 2b, well, the b's cancel out. 2b minus 2b. 18a minus 12a is 6a, and the same thing over here, 6a. Okay, I'll write that in black for us just so we're consistent with up here. 6a and 6a. All right, now comes to plugging things in. So we know 6a. We know 6a is 6, right? 6a equals 6, so a equals 1. Okay? We know that 12a plus 2b is 4. 12a plus 2b equals 4. We know 12 is 1, or we know a is 1, so 12 plus 2b equals 4, minus 12, minus 12. 2b equals negative 8. b equals negative 4. Okay, now let's move on to our first difference again. We know 7a plus 3b plus c is negative 2. Okay, let's plug in as we go. So we know 7 times 1 plus 3 times our b of negative 4 plus c equals negative 2. Okay, so 7, negative 3, this is a plus. 3 times negative 4 is negative 12, plus c equals negative 2. 7 minus 12 is negative 5, plus c is negative 2, plus 5 plus 5, c equals 3. And finally, our last one, d in black. All right, a plus b plus c plus d is negative 6. So a plus b plus c plus d is, oh, come on, negative 6. Okay, 1 minus, well, 3 plus 1 is 4, minus 4 plus negative 4, so plus negative 4 plus, come on, computer, plus 3, or sorry, this 3 goes away, plus d equals negative 6. These cancel out. D equals negative 6. Okay. So if we put it all together, okay, 1 n cubed minus 4, okay, n squared plus 3n minus 6. That is our equation for the nth term here. All right, I know that's a lot. Okay, this is This is a lot of work. I'm not gonna say it's not. With this, you could plug this into your calculator like we did before, and you could check to make sure it comes up. Now, it's obviously not going to come up with what we have here, with our terms in this formula, but it will come up with these terms here. So you can check it, make sure it works. Okay, if it doesn't work, you messed up, and you need to go back and fix it. All right.